Okay, so last time we talked about the potential for neural networks and why we're working up to what we're working up to. And now I want to tell you about how do we take this multiple inputs to one output thing that I was talking about in the previous video. So we can actually use multiple things to inform our so-called hypothesis function for linear regression, right? And I want to make it clear how we do that. So our running example is y equals mx plus b, right? Where we have this one input and we have two numbers, two constants that we, let's say we know, right, somehow magically. And we're using that to perform this computation, m times x plus b. And then we get a prediction. This is actually a prediction, not the real value, the prediction for what y might be given this value of x. But let's say now that we have number one, and then we have also number two, and number three. And let's call these like they're multiple inputs, right? So like x1, x2, x3, right? And so on. And let's say we have multiple inputs. These could be like, and by the way, these are different types of inputs. Like, let's say this could be, if we're predicting whether or not it's gonna, or how much rainfall is gonna happen tomorrow, it could be the amount of rainfall that happened today, whether or not rainfall happened today, the temperature today, the month or the year, whatever, right? So these are different types of inputs. They don't mean the same thing. And then what we could do is we could find a way to combine these through what we call a linear combination. So all I'm doing in a linear combination is, let's say we have W1 times X1 plus W2 times X2 plus W3 times X3 plus B. Okay. And that is our new definition for y. So this was our old computation where we only used one input, which was x. Now we have three inputs, x1, x2, and x3, and this is how we're combining it. We have magically we have another number named w1, and then we have another number named w2 and w3 and b. So let's say these are given to us, but we have a way of combining x1, x2, and x3 by just multiplying w1 times x1, w2 times x2, w3 times x3, and then adding b at the end. And so what you can think about here is what is happening here essentially is that we're taking each of the inputs, multiplying them by their own corresponding number. They don't all have the same number. W1 is not going to be the same number as W2 necessarily, right? But X1 is going to have its own pal, W1. They're going to be multiplied together. X2 is going to be multiplied by W2 merged. X3, W3 merged. And then you have this like we actually call this a bias term. Bias term. Oh my God. Um, and so we're just gonna like add all of these together, right? And smush it all into one number, which is our result, right? And hopefully that solves our problem. And so this is actually how it's done. In oh, I don't know what's happening here, but in logistic regression, it's exactly the same thing. Let's say we had these three numbers and we're trying to predict whether or not it's going to rain tomorrow, that being a yes or no question. What we could do is have y equals sigma of w1 x1 plus w2 x2 plus w3 x3 plus b, and then this is exactly the same thing that we did to linear regression before. We just encapsulated it in a sigmoid function so that the output is not a real number from negative infinity to positive infinity. Instead, it takes on a value from 0 to 1 that can be interpreted as a probability. So thank you for watching.